Welcome, and let's unpack storage in Kubernetes step by step because this topic is one of the pillar of cluster understanding. Pods are ephemeral. If this pod is deleted, everything will be gone. Your database, files, logs, upload, etc. But whatever you stored there should be survived. So this comes into the picture. So what is the basic idea? When the pod is deleted, everything inside the file system disappear unless it is stored on a persistent volume. So we'll see this persistent storage, but in a very brief, we are this is the introductory session for the storage. So just it's an overview. Kubernetes provide multiple ways to attach storage to the pod. If suppose I can understand this is the storage, so there are various mechanisms to attach this storage to the pod, from ephemeral volume to persistent volume. Means ephemeral volume means if this pod dies, then everything will be dies, and there is this short period of time you need that volume. So types of storage in Kubernetes. So MTDIR. So what is MTDIR? Ephemeral storage can created when a pod is scheduled on a node, lives as long as the node lives. Means if this pod is died, your storage is no more available to you. You have all seen this volume. You have seen this type of code in your YAML file. So this is the MTDIR. We already seen this type of cases. So it's for the temporary cache or intermediate build files that need not be persistent. Second is the host path. So what is the host path? So mount directory from the node file system into your pod. Okay. So that being used as a host path. So data lives as long as it is stayed on that node. So for example, you have seen this type of thing. So this comes under the host path. This is the MTDIR. So where it is useful, accessing file system like a var log or a docker socket, this could be used. And what is the risk behind it? That means if we do have a two nodes, suppose here there are two nodes, but it is specific to that node port, so it is a portable with that node. Now comes into the picture persistent volume, and with that persistent volume claim. So this is very interesting, and we must have a question on it. So whenever we are doing this demo, please be available with tan man dhan, so that you can understand and you can secure your at least 8% of marks. So this is the backbone of the persistent storage in the Kubernetes, and a cluster resource representing real storage like NFS, AWS, EBS, CC, or SHAV, and persistent volume claim. So whenever we require that persistent volume, we claim it. So you can think like PV is a storage device, means persistent volume is a storage device, and PVC is a ticket to claim that storage. Okay. Suppose there are a lot of chairs, but you can claim your one chair. That is a PVC, and a lot of chair is a PV. So you may find the YAML file here, and I'll show you in Kubernetes because it is very important. So whenever you search PERSI, persistent volume. So whenever you are creating persistent volume claim or whatever things, you just click on this persistent volume and just control FFEED. Okay, you go here, and here you will find three files. So if you want to create persistent volume, you click on this link. If you want to create persistent volume claim, if you have to click on this link and store. So persistent volume claim, you can get the file from here, and if persistent volume, you can get from here. So it is very easy for you to find this file if you are available with us in this video, because in Kubernetes examination there is very less time available, and you don't scroll there, otherwise you will lose your precious time. So anyway, we come to the persistent volume and volume claim. So then there are access modes. So whenever we get into the persistent volume, we'll check all the modes, that is storage read write mode. And because this is also very important, because whenever we are doing demo, we'll see this, but for the time being, just there are three modes, that is read write mode, read only mode, read many mode. Okay, so it is mounted on one node for read write, mounted read only by many nodes, and this is the read write many, mounted write by many nodes. So storage class is the next things that is very interesting. And boom, you can expect one question from this also. So because this is the persistent volume, and this topic you can find it in troubleshooting and things. So this could be the mini question, or you may not, but this topic is very important. So storage class is a dynamic provision. So manual PV creation works, but it's a old school type of thing. With the storage class, you let Kubernetes dynamically create PV on demand when PVC is created. Suppose you means your mama has already created rotis for use, but you want to have a paratha that day. So means it's not a good deal. So whenever you need the roti or paratha, you can ask mama to please create, and mama will create it for you. So this type of mechanism is a storage class type of thing. So it's a dynamic provision. So Kubernetes dynamically create PV on demand when PVC is created. So you can think like this also. You don't manually attach a disk every time. You just ask one, and your cloud provider will handle it. So volume types plugins. So there are this is very means everything in the persistent volume is very important. Means this storage section is very important. So if you see in examination description, you will find it's at least a 10% weightage of this. So you can expect a 10 marks question of this. So there are cloud. I'll quickly go to three. So volume types, we'll see all things in very detail, and already I do have a video for the practice for storage, but I am creating it for the course, so it is a little different. So these are the cloud, network, and CSI, the container storage interface. So is a modern pluggable system that lets any vendor storage easily. Otherwise, earlier it was restricted to container storage interface, CSI. CSI standardized storage drivers, so any vendor can integrate storage into the Kubernetes cleanly. So what is the benefit of it? Don't need to build in volume type anymore. CSI driver can handle. So these are the things, and in next video we will look all the things in very details. And thank you so much for watching, and happy learning.